Welcome back to PrepForge. This is part 2 of our NoSQL pair. Last time, Amazon DynamoDB, the fully managed one. Today, Apache Cassandra, the open source database you run yourself. Here's the key relationship. Both come from Amazon's Dynamo paper, so the core ideas, partitioning by key, replication, and tunable consistency are the same. The big difference is operational. With DynamoDB, AWS runs everything. With Cassandra, you deploy and operate a cluster of your own machines, and in return you get total control, no vendor lock-in, and the ability to run across your own data centers. In this video, we'll cover the ring, partition keys, replication, tunable consistency, how writes work with the LSM tree, gossip, and data modeling. Let's get started. Let's frame the problem. You need a database that stores enormous amounts of data, handles a huge write volume, never goes down, and ideally spans multiple data centers around the world, and you want to run it yourself, not rent it. A traditional relational database has a master, a single leader that all writes go through, and that master is both a bottleneck and a single point of failure. Cassandra throws that model out. It has no master at all. Every node is equal and can accept any read or any write. That masterless design is what gives Cassandra its two headline strengths. It's always available, and it scales writes linearly, just add more nodes. Concept 1. What Cassandra actually is. Cassandra is an open-source, distributed, wide-column NoSQL database. Two lineages shaped it. From Amazon's Dynamo, it took the distribution model, partitioning, replication, and tunable consistency, the same ideas you saw in DynamoDB. From Google's Bigtable, it took the data model and the on-disk storage engine. The defining trait is that it's masterless, or peer-to-peer. There's no special coordinator node. Every node is identical. This means no single point of failure, and it's built for high rate throughput and continuous availability, even across multiple data centers. Unlike DynamoDB, you run and tune the cluster yourself. Concept 2. The ring. Cassandra organizes its nodes into a ring. Picture all the possible partition key hash values laid out around a circle. This is the token range. Each node in the cluster owns a slice of that ring. When you write an item, Cassandra hashes its partition key to a point on the ring, and whichever node owns that slice stores the data. This is consistent hashing, and it's the same partitioning idea as DynamoDB, just visible to you. Because every node is equal, any node can receive your request. The node you contact becomes the coordinator for that request and forwards it to the nodes that actually own the data. Add a new node, and it simply takes over part of the ring. That's how Cassandra scales linearly, by adding machines. Concept 3. The primary key, partition key, and clustering columns. The primary key in Cassandra has two parts, just like DynamoDB. The partition key decides which node, which slice of the ring, the data lies on, exactly as before. Then come clustering columns, which determine how rows are sorted within that partition. So if you partition by user ID and cluster by timestamp, all of one user's events live together on one node, sorted by time, making range queries, like give me this user's last 10 events, extremely fast. The golden rule of Cassandra, and this is critical, you design your tables around your queries. You decide what you need to read first, and model the partition and clustering keys to serve exactly those reads. Concept 4. Replication. Cassandra keeps multiple copies of every piece of data for durability and availability. The number of copies is the replication factor. A replication factor of 3 means every partition is stored on 3 different nodes. If one node fails, the other 2 still have the data, so you lose nothing and stay available. Even better, Cassandra is data center aware. You can say, keep 3 replicas in this data center and 3 in another, on another continent. That gives you a globally distributed, always-on database, with local low-latency reads in each region. Replication is the foundation of Cassandra's famous fault tolerance. Concept 5. Cassandra's most powerful feature, tunable consistency. Because data is replicated across several nodes, you get to choose, per query, how many replicas must respond before it counts as a success. On a write, the consistency level says how many replicas must acknowledge it. On a read, it says how many must reply. The magic formula to memorize is, if reads plus writes are greater than the replication factor, you get strong consistency. You'll always read the latest write. A very common choice is quorum for both a majority of replicas. Prefer speed and availability? Use a lower consistency level and accept that a read might be slightly stale. This is the exact eventual versus strong trade-off from DynamoDB, but here you control it on every single query. Concept 6. How writes work, the LSM tree, and why Cassandra is so fast. Cassandra is famous for being blisteringly fast at writes, and the reason is its storage engine, a log-structured merge tree, or LSM tree. Here's the write path. First, the write is appended to a commit log on disk. That's just a fast sequential append for durability. At the same time, it's written to an in-memory structure called a memtable. That's it, the write is done. No slow random disk seeks, which is why writes are so fast. Later, when the memtable fills up, it's flushed to disk as an immutable file called an SSTable. Because SSTables are never modified, only added, a read might have to check several of them. So a background process called compaction periodically merges them together to keep reads efficient. Commit log, memtable, SSTable, compaction, that's the LSM tree, and the same engine underlies many modern databases. Concept 7. Gossip, and how a leaderless cluster copes with failure. In a masterless cluster, how do nodes know about each other and cope when one dies? Through a protocol called gossip. Every second, each node exchanges state information with a few random other nodes, and within a few rounds, knowledge of the whole cluster's health spreads everywhere. No central registry needed. When a node goes down, Cassandra keeps working. Writes meant for the dead node are temporarily stored by another node as a hinted handoff and delivered later when the node recovers. And when a node comes back, or replicas disagree, mechanisms like read repair quietly bring them back into sync. Gossip and hinted handoff are how a leaderless system stays coordinated and self-healing. Concept 8. Data modeling, where newcomers get it wrong. A word of warning that trips up newcomers. You do not model Cassandra like a relational database. There are no joins, and you should not normalize your data. Instead, you follow query-first design. You start from the exact queries your application will run, and you create a table for each query pattern, deliberately duplicating or denormalizing data across those tables so each query hits a single partition. Storage is cheap, and Cassandra is optimized for writing, so writing the same data several times is a good trade for making every read fast. If you try to use it like SQL, you will have a bad time. Model for your reads. Concept 9. When to choose Cassandra and when DynamoDB. So when do you choose Cassandra and when DynamoDB? Reach for Cassandra when you need massive write throughput, continuous availability with no single point of failure, and multi-data center or multi-cloud deployment, and when you want to run it yourself, avoiding vendor lock-in, perhaps for cost or control at very large scale. Its classic use cases are time series data, event logging, messaging, and IoT. Choose DynamoDB instead when you'd rather have zero operational burden and you're happy inside a WS. The honest summary, they solve the same problem with the same ideas. DynamoDB is managed convenience, Cassandra is self-run control. Explain the ring and tunable consistency with the reads plus writes greater than replication factor formula, and you've shown you truly understand both. And that's Apache Cassandra, and the end of our NoSQL pair. A masterless ring of equal nodes, data partitioned by key and replicated for fault tolerance, consistency you tune on every query, blazing fast writes from the LSM tree, a self-healing cluster held together by gossip, and tables you model query first. It's the same DynamoDNA as DynamoDB, but a database you run and control yourself. Across 2 episodes you've seen these ideas both as a managed service and as an open source cluster, the full picture of modern distributed NoSQL. To private but with my videos instead of Partition, head up at. If this helped, subscribe for more. Thanks for watching, and good luck in your interview.